Hello and welcome to the next episode of the ChessTDD series, part 16. As you can see, I'm getting right to the point here by moving the card over that I created at the very end of last episode where I objected to this sort of awful method that you're looking at in front of you. There's duplication, there's reuse of a local variable, so I'm, quite the hypocrite. There's all sorts of things in this method that if you've been following my blog for any length of time, you know that I'm not a fan of. So I'm going to start right off here with a refactoring. I'd kind of thought that maybe I would tease out, because this is only half implemented. It's bad and it's half done. As implemented, it only works for bishops that are in the first row. Bishops that are on the black or opponent's side of the board won't actually have the blocking algorithm implemented properly. So I had thought about maybe I'll get a better feel for the algorithm when I'm if I tease out additional cases, but this is just so icky to me that I want to refactor it right now. And I think that if I go ahead and keep adding to this mess, things will become less clear, not more. So I'm going to refactor. And I'm going to do it with, here's something to note. I've seen other people do this while pairing. It's a practice I like too. I don't know what I want to call this method. I'm not really sure. I don't feel good about this just yet. So I'm going to give it a name that sort of absolutely demands that I rename it at some point, instead of kind of deciding on some half-baked name and coming back later perhaps, or perhaps forgetting and just leaving the half-baked name in there. I'm going to give it something glaring that expresses that, well, frankly, I don't know yet what I want to call this. So that's a technique that you might find helpful in your own code here and there. And in fact, there are other sort of signals you can do like this that might be useful. I can remember at times in the past when I've had to do something in a pinch, actually giving a method a name that includes something like hack, so that anybody using it until I had a chance to fix it would understand exactly what they were getting themselves into. So be communicative in your code. Generally, it's ideal if you're communicative with good names and clean code and everything else. But if you fail at that, at least in the short term, be communicative of your failures as well. You want anybody reading to understand exactly what's going on in the code, whatever that may be. So what I'm doing here now, kind of the way this method works, and I'm not a huge fan of this, and I seem to recall this is one of the interesting parts of doing this over the course of what's going on months and months now, is that I only look at this code every few weeks, and I have no idea what I was doing before. I seem to remember struggling with a similar kind of implementation in the Peace class, and I think later, if memory serves, when I was recording this codecast, I go in and maybe put a Trello card on there for let's look and see if maybe those implementations can be merged. But struggling with whether I want this 4-parameter method. In my opinion, 4 is too many, but it seems that I don't have a lot of great options for doing this with fewer variables. We need an origin coordinate. We need to know how many spaces we're going to radiate outward. And then if we're going to encapsulate in this one method the fact that we can go in 4 different directions, we kind of need these X and Y factors, I guess I'm calling them, to represent coordinates. So what I'm doing here now is with this don't know yet method, I am going to squash and eliminate the duplication of that loop, assuming that I think I was expecting that to go green and then kind of flummoxed when it didn't. So got to back up and reconsider a little here. And yeah, oops. So eliminating the duplication and struggling with the war between the duplication and having all these parameters. And so I'm not satisfied with this, but I'm a lot more satisfied with this than I was. Now, I kind of stared at this for a minute, if memory serves, and first of all, I was trying to think of a name for this method, and secondly, I was trying to make this a little less imperative and a little more declarative. So let's see what I did first. Gotta say this part I don't remember. Oh, right. I'm looking to get rid of this idea of having these conditionals and these diagonal path blocked, I should be able to express this mathematically. The number of spaces to check is going to be the origin minus the destination, and if that turns out to be negative, you just multiply it by -1. So basically, absolute value of this. I just want to know the distance, and then for the factors, what I can do, say here for x factor, is to get it normalized to 1, which is what the method calls for. I can just take the difference and divide it by the absolute value, because then if the difference is negative, I get -1, otherwise I get 1. So I am, as part of my refactoring here, I had forgotten that I took this other intermediate step to get rid of the conditionals, which is something I wholeheartedly advocate. The more you can eliminate conditional and branching logic, the better. Then I think I was a bit confused as to why things weren't working, and I accidentally got into another place in the code I wasn't interested in. Don't remember exactly what I was checking, which is sort of scary because I think I wrote this code only about 3-4 hours ago. But oh yeah, let's. So I'm going to try and find out which test is failing and why. So that's interesting. This case for a whole other piece that I haven't touched in a long time is failing with index out of bounds exception 5,2 from 5,1. So why is that happening? What I want to do is say, just show me the coverage for this test. So on this line where I'm calling it, it's throwing an exception here as I'm calling it. So what I'm going to do, and this is a little... And I think I'm going to revert to this. I'm extracting a local variable because I kind of want to see and break up where the exception happens. So is that a refactoring? Yes, but it's also a debugging step. So it's kind of maybe a bit of a gray area in TDD. It's an extremely low risk refactoring to the point of being, I can't say a no risk refactoring, but it's a very low risk refactoring. So I don't feel too bad about it when I do it. Anyway, so what I did there is I'm kind of putting the method back to where it was green and then uncommenting to see what happens, kind of confirm that, yes, this is still going red. So now I go back to my extract local variable, see if I can tell what's happening, provide a little bit of clarity to see if I can get everything back to green. So as I said, you shouldn't really be refactoring when it's red, but this is extracting locals is a way of separating up this statement so that I can have a better idea of where and why I'm getting a failure. So what I realized in the course of doing this was that I was essentially passing in the wrong argument. I had sort of gotten ahead of myself there. So now everything is green, and I've got my more declarative way of expressing this, and there's no longer any conditional logic. All the conditional stuff is happening in the math instead, using this kind of cute trick of absolute value and actual subtraction in order to determine what essentially this x factor and y factor thing amount to is determining the quadrant direction I'm going. So if I'm at a given coordinate, if both are positive, I'm moving into quadrant 1. If both are negative, I'm moving into quadrant 3, that sort of thing. So we did a little bit of this before here, a bunch of episodes ago, probably in the bishop piece. And so, like I said, I think that there's probably not great duplication here, and that I might spend an episode or even two where I kind of look at these pieces of logic and try to abstract something common. I'm not in love with the fact that some of this stuff isn't implemented in the base piece class. I've just over the years come to really not like inheritance, except in, very narrow, specific kinds of cases. So it's especially a smell if you're moving something up into a base class to avoid duplication, and then you're using that same logic and repeating it somewhere else in the code in something that's not an inheritor. That to me is kind of telling me as we go, gee, maybe that belongs somewhere broader, that both the pieces and the board can make use of it. So I think that's something important to consider. And maybe in that whole bit of refactoring or overhaul, we can start getting rid of this situation where you've got 4 method parameters. It isn't a hard, fast, or absolute rule. that you need to have 3 or fewer. It's a rule of thumb for me. I have to say, as methods go, these parameters are fairly straightforward. I don't think they're overly hard to understand. I could combine X factor and Y factor into some kind of ad hoc type, or, maybe I could use the coordinate class that somebody, I think it was called coordinates, suggested to me in the comments of one of the posts. So there are some options. Those are sort of micro optimizations in a scenario where maybe a slightly broader reconsideration is in order. But anyway, I'm making the best of it here, and what I'm doing is I'm getting away from this imperative looping, and I am moving towards declarative. So I'm saying, let's take these parameters I've got, and with a sort of dense statement, but is sort of understandable, spaces in the board to check. So I'm going to turn all these things into a series of squares that I want to check for blocked. And then I'm going to return true if any of these squares are blocked. And that's going to tell me if, from one diagonal spot to another, there's pieces in the middle. So is directed diagonal path blocked was the name I came up with. I don't know if it's absolutely the best name, but I think it's clearer than dunno yet, and I think it expresses what I want to do. So is diagonal path blocked breaks the X, for the moment, just X, directional quadrant, whatever you want to call it. It figures that out and then calls is directed diagonal path blocked, meaning, okay, now I'm calling this other method now that I know what the direction is. So far, all I'm doing is passing in 1 for the y direction. So we're only advancing on the board, which is reflective of reality. All the test cases are passing except, oh wait, no, they're not. Uh-oh. This threw me for a loop, and it's something I made note of in the lessons to take away. I was so focused on what I was doing, I had forgotten that I had turned off coverage for all but the one test, and I didn't notice that I had gone red. When that happens, you see what I'm doing here? Just Control-Z through everything until you're green again. When you realize that you've been doing a refactoring and you thought you were good, but it turns out you're red, don't go on and try to fix it. That's it's tempting, but it is there's dragons down that road. You don't want to do that, because then what happens is you don't know, you're at an error point and you haven't had tests driving that. You don't know how you got to that error point. And so if you continue to go on and break things, you don't know if what you're doing is you've lost this sort of one-to-one relationship between inputs and outputs. You might be further breaking the test. Maybe the test is now broken in 2 spots. You don't know, 3 spots. Who knows? Maybe you're breaking more tests if you're not keeping a close eye on it, just looking for red, green. So be careful of that. And my recommendation is wholeheartedly, if you notice that you're red when you're doing a refactoring and you didn't expect it to be red, you're not in the middle, you're at the aha, everything's good moment, and then you look and see red, go back until you see green. Trust me, it's not going to be that hard to reconstruct what you were trying to do. You always want to start from green when doing a refactoring, and get back to green as frequently as possible, because that's sort of like if you're typing some kind of document, hitting save, that's your good state. So what I'm doing now is, after this refactoring, the code I'm looking at is a lot more readable. It doesn't have loops. It's not duplicated. I'm not reusing local variables. It's a cleaner playpen in which to play. So I feel good expressing this next test here, which is, I'm going to say that when I go get the available moves from this bishop on the opponent side of the board on row 8 in the normal setup, or no, I'm sorry, this is in the one where there aren't pawns. So what I'm expecting here, if this were working right, is that no pawns in the way, there should be moves for this bishop. However, I see that there aren't. Now, in the middle of doing this, I had a completely random thought, and I made note of this too. I wanted to maybe implement this in the class where there is the actual beginning setup, and maybe just move one of the pawns. But then I remembered, as I've sort of happened on in previous episodes, oh yeah, I haven't done move piece yet. So I keep forgetting that, and then I keep going into the code and saying like, oh, I'll just move a piece, and then I keep thinking, oh, right. Yeah, I don't have moved piece, so I don't want that to happen again. I want that to be on my radar. So if something occurs to you like that, note it down, or you'll keep kind of forgetting it and putting it off. And as I'm looking at this, I see that I reverted back to dunno yet as the method name, and I'm wondering now if I ever fixed that as I went on. So I guess therein lies the peril with blindly undoing everything you did. But you know what? I will take this in a heartbeat over kind of slogging through from red and trying to get back to green when I don't know what I'm doing. Pretty easy to rename methods. So now I've kind of got my eyes on the prize here, and I know that that I've gotten this test to pass, but I want to, and my hypothesis is that now with what I did with Y, it takes care of all of the cases where you're going into quadrants 3 and 4, all of the cases of blocking for the opponent's side. But I'm going to write a test where I block, and then I'm going to get the moves for this bishop and assert that it is in fact empty. And there's nothing wrong with writing a test that you expect to go green to kind of confirm and make sure that your understanding of the code is correct, because test-driven development requires that if you want to change the behavior of the system under test, you need a red test in order to do that. But it doesn't say that you can only write tests that you expect to go red. I'm expecting green here, and hopefully I'll see it. But if it doesn't, then hey, I've got a red test and a behavior to correct. If it does, I haven't lost anything. I've got a test that makes sense and matters. And I feel more confident in the system, confident enough to move that card over. So now I am going to, please tell me I remember to rename this. I guess not. I was kind of looking around a little bit in this class to figure out what I wanted to do next time around. Oh, come on, you're right over it. Sorry, it's a little bit late, and I'm, oh, I remember what I was doing here. I was sort of trying to get a feel for how I might do a broader refactoring, and you type static before it to see what it's using that's an instance level thing, and then I say, oh, there's this get piece here, because I was starting to think maybe I could just pull all this logic out to a common place. Getting a little ahead of myself, putting my cursor on a method named dunno yet, failing to see that it was there, so I don't know, maybe somebody should like throw a comment at me to remind me to do that next time, because I'm also, you know what, I'm going to put a Trello card in, even though you're not seeing it on the screen. I'll go do that right now because I don't want to forget that. That's a little embarrassing. So next time around, if you see a Trello card up here that wasn't there last time, that's why I went ahead and did that out of band. So now I'm just saying, this was kind of the recon I was doing at the beginning. Let's figure out something to do with this logic later. And that's it. Thanks for watching.